Okay, here we go. He told me, "Don't tell me what to do." And I was like, "Well, okay." Here we go. Hey, quiet. Okay, let's get started. No more talking. All right, so I'm going to get started on this. I'm going to try to record this and see. My microphone, like I said, is not good, but I'm going to do the best I can. So you guys try to be quiet as much as you can. All right. Okay, so this is chapter 5. Okay, as we start chapter 5. Okay, a function. Has anybody ever heard of a function as far as math goes? Okay, what I want you to think of a function, okay, it's kind of like a machine. All right? If I have a machine and I put something into that machine and it gives me a result, it's kind of like a copy machine. Okay, I give the machine a copy that I want to make, and what does it do? It makes a copy. Okay, a function has an input and has an output. Okay, the function is like the machine part of it, the rule part of it. Okay, does that make sense? All right. So let me explain how this works. Okay, this says if the input is 3 and the relationship is x plus 2, what is the output? Okay, so when I say it has an input and an output, this x plus 2 is the function. Okay, so if I have, let's say I got this machine right here. Okay, this machine has x plus 2 on the outside of it. That means whatever I put in represents the x, and whatever it puts out represents the answer. So if this machine is x plus 2, and I put a 3 into it, what do I replace that x with? A 3. So 3 plus 2 would give me what? 5. So the output would be a what? A 5. Input is 3. Rule, or the function, the relationship is x plus 2, and the output is 5. Okay, does that make sense? Okay, that's how we determine that. Okay, kind of like the way this looks. Okay, inputs, relationships, and outputs. Inputs are ingredients. The relationship is the recipe. The output is the voila. Okay, so it's kind of the same thing as it is like a function is kind of like a recipe. Okay, you put all the ingredients in, you mix them. Okay, the recipe is actually the function table, the rule. Then the output is whatever I was wanting to make, right? Okay, just like I said, you could think of a function like a machine. One number goes in, one number comes out. Okay, all right. So functions basically have, now here's the deal. Okay, if I have a if I put a 3 in, remember my function rule? What was my rule? X plus 2, right? If I put a 3 in, the only thing that's going to come out is a 5, right? No matter what, if I put a 3 in, I'm not going to have two different answers, am I? Does that make sense? Okay? So that makes, if I have something like that, that is not a function. Okay? So for example, if I put a 1 in and my output was a 2, it's only going to be a 2 if it's truly a function. Okay? One input cannot have multiple outputs. Does that make sense? Okay? And we'll go over how we graph functions eventually. Okay? All right. So let's look at, um, I want you to start writing your objectives in your notes. Okay? So your objective, okay, what you're going to do today, write this down. You're going to understand, all I want you to write is the first part. Write this down. Objective, in your notes, objective, dash, and I want you to write, understand that a function is a rule that assigns each input exactly one output. Just write that sentence for me, please. Okay? That's what I want you to write for your objective today. Okay? Understand that a function is a rule that assigns to each input exactly one output. That's your objective. So by the end of this lesson, you're going to understand what a function is, and that it's basically a rule where you have one input and one output. You understand? All right. Does everybody have that written down? This is actually really easy, guys, once we get the hang of it. Okay, let's continue then. Some of the things you're going to learn vocabulary-wise. Okay, we've already talked about what exactly a function is. Okay, we know what an input is. Input is what you put in. Output is what comes out. Okay, a relation. Okay, relation is the relationship that input has with the output. Okay, and then a vertical line test. And I'll go over what a vertical line test is, because when we graph a function, okay, you'll see a vertical line test can also determine whether a line on a graph is a function. That's easy. First of all, what does it mean, vertical line? What does vertical mean? Up and down, okay? So it's a test that you do on an up and down graph, okay? All right. Okay. So if we were to look at this question, actually, I'm just going to go over this. Okay. A mathematical relation exists when two mathematical values are related in some way. A relation is any set of ordered pairs, and typically that's x, y. Okay, the input of the relation is a set of x coordinates. The output is a set of y coordinates. Okay, listen to what I just said. The input is the x coordinates on a graph. The output is the what? The y coordinates. So, if I was going to think about that relation that we had at the very beginning, what was it? X plus 2, right? So if we have an x value of 3, what was the y value? No, remember, x is 3. The rule is y is x plus 2. What was the y value? 5. So if I had x is 1, what's the y value? 3. If I have x is 0, what's the y value? 2. Okay? In other words, every x value that you put in is going to give you a y value. Does that make sense? And if you were to graph that, when you graph those lines, it would make a straight line. Okay? I'll show you what this means. Okay? All right, so let's take some ordered pairs here. Okay? -2, 0, 3, 0, -1. Okay? And then if I had a table, I was to put these in. Okay? These are the same ordered pairs. I just put them in table form. Okay? So I have a -2, 3, a 0, -1. These are the same thing, aren't they? They're just listed in a different way, right? Okay? If I was mapping them, what do you think mapping means? Okay, you're basically putting a table. It's like you're taking this -2, 3, 0, -1. All you're doing is you're taking, just like matching, okay? And then if I were to graph them, okay, to graph all those points, this is what they would look like, okay? Do you understand? I'm not telling you whether this is a function or not, but do you understand the 4 different ways that we are expressing these numbers? Okay. All right. So let's take a look. If I have, okay, this first one, all right. Okay, we're going to move. I want to skip to exactly. Okay, so we're going to do mapping diagrams first. Okay, so we're going to identify if these are a function. Okay, first of all, let's look at this. Okay, just look at that mapping and tell me if this is a function or not. How many of you guys say yes? How many of you guys say no? Okay, why is it not a function? Benson, why is it not a function? Cannot have two outputs, okay? Now, in other words, let's just say that the rule of the function, okay, was x plus 2. Same one. Okay, if I put a 1 in, I'm only going to have one answer. I can't have two answers if I put in one input, can I? Does that make sense? Okay, because you can't have two different outputs for the same input. Sorry, this takes a while to load. Okay? So this is not a function because why? The input value 1 has more than one output. So this is not a function. Okay, does that make sense? Why that's not a function? Okay. All right. So look at this mapping diagram of these numbers. Okay. Can this be a function? Listen to my question. It looks confusing, doesn't it? Because the output, I have two of the same outputs, but does every single input have only one output? Look, this input has one output, this input has one output, this input has one output, this input has one output. So is this a function? You guys say yes? Each input is mapped to exactly one output. Exactly. Very good. Okay. So when we have tables, okay, tables are just expressed, remember, we have order pairs that express as a table. It's the same kind of thing. Whoa. Okay. All right, so these are my inputs. I have 1, output is 2, 2, output is 4, 3, output is 6, 4, output is 8. So here I have 1, output is 2, 1, output is 2, or 1, output is 4. Okay, do you understand why this is a function over here? Why is this a function? Somebody explain it to me. Why? Brooklyn? Read this. Yeah. Okay. And why is this not a function? Somebody. Because the input what? Has more than one output. These are the same inputs, aren't they? But this input would say I have a 2 and I have a 4. This is a 3, I have a 6 and I have an 8. That does not represent a function, does it? Okay. So let's look at these tables and determine if these identify as a function. All right. Look at this one. They're trying to make it confusing. Why? Because positives and negatives. This has one input. How many outputs do I have? One input. How many outputs? One input. How many outputs? One input. How many outputs? Can I have the same outputs? I can. My y, remember, x's can't be the same, but y's can be the same and it can still be a function. So is this a function? Yes. Okay. Good. Uh-oh. Oh, sorry. I wrote the wrong thing there. Okay. The input values that correspond to more than one output. No, so this relationship is a function because each input value has exactly one function. Good. Okay, look at this one. All right, so if we look at this, you can tell just by looking at this table, is this a function? Why not? Because I have 6 has a 3 and 6 has a 5. So this is not a function because the input 6 has more than one output. Good. All right, does this make sense so far? Okay. All right. Now when we do a graph, okay, remember all of these functions, all of these have an x and a y value, which means they can be graphed, right? Okay. So you see this vertical line? Okay. I'm going to move it from left to right. Tell me if it ever crosses, the green line is the graph, okay? This green line is what we graph. Does it ever cross it more than once? Does it ever cross it more than once? No. Anywhere I move this this vertical line, the line that's graphed only crosses it one time, doesn't it? Okay? But if I have this, okay, did it already cross more than once? It's crossing it more than one time, right? So if it ever crosses it more than one time, that means it's not a function. Does that make sense? Okay? So would this be a function? No. Okay? It's not a function because the vertical line intersects at more than one point. Okay? So no matter where I put this, it's going to cross it more than once. Does that make sense? That's why that's not a function. Okay. So if we have a graph of these lines, all right, determine whether each relationship is a function. Okay? What do you think? If I was to do the vertical line test, okay, let's just say I have a vertical line, okay, and I'm not sure it's going to let me. Okay, let's just say I have this line that goes across, okay. If I was to move it across, right here it crosses what? One point, but right here what happens? Is it crossing in more than one point? Yeah, and here it's not. So what do you think this is going to be? Is this a function? This is not a function. Why? Okay, the input of 2 has what? Why is this input 2? Because my x value is 2. It has a y input of what? 3 and negative 3. So does it have more than one output? So does that mean it's a function? It is not a function. Good. All right. Let's take a look at this one. Okay. Just look at it. Can you tell me if it's a function or not? Why is it not? Because look at what is the x value? What is the input of these 2 points? 3, and I have a 3. Let's look at 1, 2, 3, 4, and a 3, 7. Okay, so this is not a function because at least one input has more than one output. You guys agree? All right. Okay, so you understand how to do that. Now, sometimes it doesn't necessarily have to be a straight line, okay? If you had a graph, what if I have something like, even if it's not a straight line, but let's say, like this. Yeah, if I drug this right here, it doesn't matter. Eventually it's going to what? It's going to cross the more than one spot. So is that a function? No. Does that make sense? Pretty easy stuff. All right. Okay. All right. So we actually identify it using a graph. Okay. Look at this line. Does that represent a function? How many of you guys say yes? Yeah, no matter what, if I drug a line all the way across this, it's never going to cross more than once, is it? Okay, so does this pass through any more than 1 point? No. Is that a function? Yes, it is. Okay, look at this one. Okay, if I was to drag this across. Now, remember what I told you? You guys think it's a function? If I drag this across. Okay, let's just use my pointer. Okay, I drag this across. Does it ever cross that line more than once? Yeah, can you say it's a function? It is a function because each output has at least or exactly one input. Okay. Does that make sense, guys? Not a difficult lesson. Okay. All right. So remember, is this a function? Is this a function right here? Is this a function? Yes. Good. All right. That's it. So what I want you to do, if you will take your books out. So I told you, easy lesson today. We are going to do pages 261 and 262, 1 through 7. 261 and 262, 1 through 7.